Okay, as promised, we are back with one more video on the inverse trigonometric functions, and we're going out to the tree house. Okay, out to the tree house. Here we go. So here's the tree house. I'm going to show you where, when building this tree house, I got to use some cool stuff using inverse trig functions. Okay, a few videos ago, I was talking about, if you noticed up here on top, these rafters are at an angle. They're down here at this base, and you can kind of see the triangle right here, and then you can get that triangle. So I'm going to pull that triangle out, make it a little bigger, and talk about what I did with that. Okay, so this here, I know that is 7 inches. That's two 2x4s stacked on top of each other. Funny thing is, 2x4s are not 4 inches wide, they're 3.5 inches wide. So two of them, 7 inches. Okay? And so two dots like that, two little lines like that mean inches, 7 inches. And I know that is 6 feet. So one line is 6 feet, which equals 72 inches. Okay? So what I really need to know is I can use the Pythagorean theorem to find the length of that side. I'm not going to do that right now. I think I did that in a video previous about this. But using this inverse trig functions, what I need to know is this angle theta here. So when I'm cutting, let's draw a board out here. So imagine here's your board, and so you need to know this angle theta so that you know how to cut this thing here so that you get things flush. Okay? So to figure out theta, I can say I need the angle, I know the opposite side of my triangle, and I know the adjacent side. I know the rise over the run. That gives me the tangent theta. Tangent theta equals rise over run 7. Oops. Started my calculator, and let's give it a second to warm up. TI Smart View emulator software. So tangent of theta equals 7 over 72. Okay? And that's going to give me that the inverse tangent of 7 over 72 equals my angle theta. Okay? So I'm going to get a theta approximately equal to the inverse tangent, and let me see what mode I'm in. Let me go in degrees. So I'm in degrees there, so second quit, and let's say the inverse tangent is right there. So inverse tangent of 7 over 72. I seem to remember this being about 4 degrees. Let's see, 5.55 degrees. Okay, so that is going to be about 5.55 degrees will be the angle I need to figure out these cuts there and there. If you think about it, well, time here, so you know that if you know this angle is 5.55 degrees, then you know this angle right here on the board, oops, the angle that you need to cut there, you need to make an angle of what, 180 minus 5.55 degrees, because 180 degrees minus 5.55 degrees, because if you want a straight line here, you know that thing is 180. And if you know that this angle is 5.5, then you know that this angle in here is going to be 90 degrees minus 5.55. And then the same thing that will allow you to get this angle. I don't want to get too much into that, but if anybody is interested in using this kind of stuff in this way, shoot me an email. We'll talk. Okay? I want to use one more example here. So if we look at the tree house, let me go to a new page here. Insert Okay. So let's look at these beams here. Okay. So let's talk about how I figured out how to get those beams. So that beam there, what I did was measure straight down here, and then got a level board here to make a right angle and measured that. And I don't remember the exact measurements, but let's say that this was 7 feet. Here was about 7 feet, and this one was close to 7 feet too. I mean, because I wanted these things to be 45-degree angles. Let's say it wasn't quite 7 feet. Let's say it was what's 6 times 12? 72. So let's say it was 78 inches. Okay, so that would give me the 7 feet. Is what 7 times 2 is 14. 7 1 7 84. 84 inches. So let's draw that triangle there. That has a height of 7 feet. So, and 7 times 12 is 84. So 84 inches. And we have this side here, and we measured it to be about 78 inches. Okay. And then we could use the Pythagorean theorem to figure out the length of the board, but then we need the inverse trig functions to figure out the actual angle there, so that when I do get the length of the board, so when I get my board, that I actually know how to make the cuts on it. Think of the board as like that, and we want to make this thing flush there so that it comes up in here flush against the porch there, and we want it to be flush here, and actually I'm going to flush like that so it fits in a little slot right there. Okay, so you got to know this angle theta, and it will tell you everything. So again, I need theta, I know the opposite, I know the adjacent, so I'm going to use the inverse tangent. So I know that tangent of theta equals 84 over 78. That tells me that the inverse tangent of 84 over 78 equals my angle theta. And so the inverse tangent, oops, I didn't get the inverse, did I? Second. There we go. The inverse tangent of 84 over 78 better be close to 45. (47.12 degrees). This is about 47.12 degrees. And if you think about it, at 45 degrees here is going to give me the most support, but just depending on the tree, you might not be able to go in at exactly 45. You got to do what the tree will let you do. So here, if I would have made these measurements, and I did make something that I don't remember the exact measurements, but we did this to build these beams here. So we've got another one there, we've got one there going to that corner. On the back side over here, we've got one going to the corner of the back of the treehouse. Okay, so again, really cool example. This stuff is very useful. Trigonometry is amazing, and it can just do so much for you. Okay, hope you enjoyed it. Next video, we'll be talking a little bit more about inverse functions. One more video on inverse functions. Okay.